Hi class, it's Bill with the final, I promise, video on our week 3 demos, and this one's going to focus on testing. You'll notice that we've covered all of the stuff. We made our program work really well, but what we didn't do is do unit testing, individual testing on the functions that we created. So let's go back and let's do a little bit of that. It's a great practice for us. So the thing that we want to do is we want to create another method that's just for testing. So I'm going to come down here, I'm going to press Control M, and this one's not going to have any parameters or anything, but it's going to test the conversion functions. And then I'm going to get rid of these because it has no parameters and it has no returns. It actually does its own thing. So that's pretty good. In fact, I can get rid of one more. There we go. And this is going to be a public static void, and it's going to be called test conversions, and it's going to have no parameters and no returns. So what we want to do here is we want to think about, for each one of our functions, can we do some testing to make sure that that function is acting as appropriate? So is it returning the right stuff in all the cases that it would be expected to? So the first thing that I'm going to do is I'm going to do a little system out println. I'm going to make sure I sort of start and stop these so it's very easy to see. So I'm going to do a little kind of banner that says conversion tests starting. Any failures will be noted here. All right, so that's an easy little start. I just want there to be a start and stop for this. So at the bottom, I want to do something very similar, which is going to look something like this. And I'm going to tab that back. Okay, so that way when the users see that sort of start and stop, they know that that's where the testing was. And then if there's any failures, they're going to see them in here in the middle. So now let's test one by one each of the functions that does the conversions. Now, testing code can be as long as and as complicated as your other code. So it's not something to take lightly. You actually have a lot of work to do this testing. Now, what I'm going to do to make life easy here is I'm going to create some doubles for the input, expected, and the result of the particular test that's been run. So I have those variables, and what I'm basically going to say here is for each of these things I'm going to set an input, and an easy way to do that is to take the table and go pick some random value out of that. Now, random values are generally not good testing, right? It's not what we want to generally do, but since these are kind of easy conversions, probably if you tested a couple of different points, they would be useful. So I would suggest maybe places where the two are, either of them are 0. So in this case, where Fahrenheit is 0 and where Celsius is 0, that would probably be some good additional tests. But I'm not going to do those just now. I'm going to do one to show you in just an example. So I'm going to say if I take 572, I look up in the table and say that that's going to be 300. Now remember, type all of these in as doubles. It's very easy to do your calculations wrong and get values that don't work. So type doubles and put zeros and everything, dot zeros. Okay, now the result of this is going to be, let's say, F2C input, and I'm going to let me break these up here. I want to be a good coder here for you. Okay, so I'm going to do the input here. I'm going to pass that here, and then let's see what happens. And then I'm going to say if the result is not equal to the expected, then I'm going to say, open parentheses and system.out. Let's go back here, .out. And I'm going to say something like F2C failed converting. And then I'm going to smush on what the input was so that I can see in the failure message what I tried to convert. And then I'm going to put a semicolon and I say what I expected. And then I'm going to smush in, concatenate in what the expected was. And then let's see if there's anything else. And then, right, I expected that. All right, let's see, make sure I know where I am here, plus expected. And then I'm going to say comma, but got, and then I'm going to tell it what I actually saw, which was the result. So it's kind of complicated, but if you parse that out, I'm just saying this failed converting this value. I expected to get this, but I got that instead. Right, so it makes sense if you stop and look at it. Now you might want to break that over a line, or construct the string more carefully if you want, but that should work. And then I'm going to close my parentheses, or my curly brace. All right, so I think I have something working. Let's see if that compiles. Not a statement. Okay, so input equals, yeah, okay, so that would be important. Okay, so there we go. So that works. Now let's go run it and see if the thing works. So let's go back here and let's run the guy. In this case, I'm running test conversions, and I'll go look at my output window. And okay, so it started and it stopped and everything looks good. So I can keep going. Now, what you're going to find, let's keep going with this, but what you're going to find is that this code gets very, very long. The test code will be many pages. The general rule of thumb for functions is you want the function, the top of the function and the bottom of the function, to be accessible if you do page up and page down. If it gets longer than that, you want to break them out because they're too long. That's a good rule of thumb. In this case, the test functions are going to get crazy long because there's just a lot of individual kind of tedious code. So one of the things that I do here, it's not a good thing to do in your regular code, but in the test code only, I let myself have a little flexibility on spacing, and I do the following, right? It looks terrible, but it'll actually look parallel in the end. And I also let myself relax this requirement of always using brackets on an if. I get rid of that altogether so that everything fits on 2 lines. And so each one of my tests can be 2 lines instead of 8 lines or something like that. Again, I don't recommend doing that. Please don't do that in regular code, but in your test code, sometimes it's just needs to be dense so that it's easy to put in these values and get the results. So you'll see that works pretty well. Let me paste in the rest of them for you. Okay, so you've seen I've pasted in all of these things. Right, so there we go. And so each of these is pretty similar, where I just set up the input, the expected, the result, and then I have a similar message. In fact, I basically pasted this whole line and just changed the name of the function. I could certainly pull that out and put a variable on the first line, and then these second functions, these second lines, would all be completely equivalent. In fact, you could make that into a function call that would make this whole thing simpler, and then your test cases here would be 1 line each, which would be a call to the other function, which I like a lot. So think about that. But at the moment, everything looks good here, except we have one little bitty problem. Let's go compile this. Compiles fine. Let's go run it, and let's see what the results are and see if we have everything working right. Well, we have a little problem here. I was expecting 233.15, but I got 233.1499998. Why does that happen? Well, floating point numbers are stored imprecisely. This kind of thing happens, right? You always get round off errors in many cases, so that's actually not that unexpected when you're working with floating point numbers. But our tests pointed out that, at least we saw, hey, the rest of them passed, and these are the only 2 that failed, and they have the rounding errors. So what we probably want to do is build in some generic error handling or rounding for that. So let's clear that. Let's come back and let's fix that code. So an easy way to do that here is, rather than just looking at the input this way, where we just call the result, call result equals this, why don't we actually round this off? So in this case, let's do math.round, and then we're going to round. And remember, math.round takes 1 parameter, and that is what the thing is that you want to round to at the decimal point. So we need to multiply this by 100. Now be careful, I made this mistake. That's not what you want. You want 100.0, right? Because you want to keep this all in the floating point realm for all of these operations. Once it's rounded it to the decimal after you multiply it by 100, we want to divide it by 100.0 to move the decimal back over. So this takes it, multiplies by 100 to move the decimal place over 2, then rounds it to the nearest value at the decimal point, and then divides it to move the decimal point back. So now, if we do that to all of our other functions, You can see that we have now rounded all of those. Again, this is another, good reason you might want to be able to pull some of this stuff out and make functions out of it. The only problem is we're calling different functions each time. That makes it kind of hard to genericize it all completely. But anyway, you get the idea. That compiles now. Let's go run it and see if we now get. Yep, we got no more failures, so everything looks good. Now, by the way, I was a test software tester for a lot of my career. Be suspicious if everything passes the first time, right? Go back and test, cause some failures, put some unexpected values in, and make sure that you're getting the right behavior, because test code is still code. So expect that there are going to be bugs in your test code. There always are. Now, one last thing that I want to cover before we're done. Again, I mentioned we want to do more testing here. One value is not really enough because they have this scaling and offset type conversions. So you'd probably want to test the 0 points. You might want to do a couple tests for each one. A random value from the table is really not a good test approach, but I just wanted to show you an example. Now, the other thing that we haven't tested, you want to think about testing everything that your code can do. How about this? Right? Your code says it's going to throw an illegal argument exception if you pass it negative values. We haven't tested that. We need to test that, right? So how do we test the preconditions? So for instance, I want to do that here. I want to say test the K2C precondition. Right? So how do I do that? Well, if I try it, let's say I'm going to do something like this, right? I'm going to set input equals, negative 0.05 or negative 0.5 or something like that. Expected doesn't really matter because it should blow up, right? Result equals, and then I'm going to call math.round and K2F with the input, and I'm going to say times 100.0 and divided by 100.0. Right? So that's fine, except what I'm expecting is that should throw an error. Now, this is not handled till later in the book, right? In terms of catching errors that are thrown, it's covered later in the book. But hey, if we're creating the throw, we really need to be able to test it. So we kind of got to get into it at this point. So the way that you do that, and if you took Python, you are aware of try catches, and this shouldn't look all that unusual. We take the dangerous code. This is the dangerous code, right? Because that could throw an error, and we surround it by put it in a try block, and then outside we catch it, and in this case we know it's going to throw an illegal argument exception, and that is the object type, and we're going to declare an object a variable of type named E that is of that object type, and then we are going to catch that error. Now that's the typical try catch logic, right? Try this thing. If an error happens, if it's this particular error, come down and do this code. Now, test code is a very interesting thing because we expect the error to happen. We're actually thinking if the error doesn't happen, we have a problem. So weirdly enough, nothing goes in the catch, which would be very different than we do in normal try-catch code in our production code. But in test code, the exception is in fact the expected behavior. So what I can come do here is I can come and say out.println, right, K2F precondition failed. Input of, and then we can continue the rest of the line, and I'll just paste that in because, yeah, here we go, because it's easy enough to do. Input of, right? So we say input of whatever the input was up here did not throw an exception as expected. So this is weird looking code in a way, but it's actually the exact code that we want to test that precondition. And again, and you have to sort of look at that and say, I'm going to try this thing. Now, notice this line would not be hit in case the exception is thrown, right? If the exception is thrown, it's going to come down to the catch, which is what we expect. So this line is only going to be printed if in the case that the exception did not get thrown. Again, this is totally backwards from how you'd use try catches in production code, but you have to think about, I want the error to happen. This is the good thing, right? The error is the good thing here. And then I can do the same thing on the other one, and I can do my precondition for the other one, because we've got K to C and K to F. This is K to F, sorry. All right. So we compiled that. It works. I go and run the guy, and let's see now if it's working. Test conversions. Go find our output window, and no failures. Everything is looking great. So this is really interesting stuff, right? Writing all this test code is important to understand. Thoroughly testing your functions is going to be something you're going to want to do in the real world. You want to always have unit tests to prove that your functions can do everything that they advertise. Writing that test code early. So for instance, when you write the function, write the test code. Some people would say write the test code before you even write the function, because once you've thought through the test cases better, you're going to write the function better. So do those things and be ready, because I promise in these upcoming assignments, you're going to be expected to write test code for your objects, and they are not easy to test. You got a lot of thinking to do. And again, I said I would relax my expectations to make the code a little smaller in the testing area. We actually are kind of making it more dense than we would normally want, and we're using what would be considered sort of bad behavior here on ifs, which is not using the curly braces, which we always recommend in the production code, but we're short-handing them here to make things look a little bit easier. So we finished the demonstration, and I've given you some bonus information on testing, which I hope that you take to heart. This is an important thing, and in this day and age, it is less common to have testers looking at your code after you write it. It's more common for you to have to do the testing yourself the best you can. So this is a great start for that. So thanks for watching all these videos. I don't always know how many they're going to be. In this case, we're at 4, but I hope that they're all extremely useful in walking through this material and seeing how they apply it and what the thought process is as you walk through. So I'm hoping that that's very useful to you. Give me some feedback and let me know. And thanks for watching the